The quadratic formula is probably one of the most famous formulas in all of algebra. There's a good chance you've already seen it. And usually the way people think of it is just a magical formula that somehow can solve for x in any quadratic equation. And that is true. But rather than me just telling you that it's a magical formula that always works just because, I'm going to show you why it works. What the quadratic formula essentially is an equation that simplifies all of the steps of completing the square into one step. It condenses the entire process into one long fraction. So what we're going to do is actually derive the quadratic formula using completing the square, since that's what the quadratic formula essentially is. It is the derived form. So what we start with in any quadratic equation is something that looks like this. Negative 2x squared minus 18x plus 1 equals 0. This was actually one of the problems that we did in the last video, I believe. And this is in the standard form of a quadratic equation. Ax squared plus bx plus c equals 0, where a, b, and c just represent the coefficients of the x squared, the x, and the constant terms. So what we're going to do is complete the square in both of these problems side by side. Now it's a little trickier to do that for just using letters, but I think it'll be a little easier to understand if instead of just seeing the steps randomly, you actually see how they connect with the completing the square method. So let's get to work on this problem on the left here. The first thing we do is factor out a negative 2 from the x squared and x terms. So we factored out negative 2, the coefficient of x squared. So here the coefficient of x squared is a. So we're going to factor out a from the x squared and x terms. Now how do we factor out a from bx, since there is no a here? Well, factoring out just means dividing by that number. So we're going to divide bx by a, and it will become b over a times x. It could also be bx over a. All we did was divide bx by a. The x is still would be the same as if it were in the numerator here. I'm just going to write it like that to make it a little more clear for this problem. Okay, the next step in completing the square is we do double parentheses here, x plus half of this number, x plus 9 over 2 squared. So let's do that over here. We'll have a double parentheses x plus half of b over a. Half of b over a is b over 2a. We just divided the whole thing by 2 by putting 2 in the denominator. Squared. Then we do minus this 9 over 2 squared. So minus 81 over 4. Close the outside parentheses. Minus b over 2a squared. So that'll be minus, we square the numerator, b squared, and we square the denominator, 4a squared. Squared the 2 and squared the a. And then we just write what's left over on the outside. Whoops, don't want to forget that. Close parentheses there. This whole thing is being multiplied by the a. Okay, and now we know that we bring out this number from outside of the parentheses by multiplying it by this coefficient in front. So the x plus 9 over 2 squared stays being multiplied by the negative 2. But now we have negative 81 times negative 2, which will be positive 81 over 2. Remember, when you multiply by a number, you can also divide the denominator of the fraction by that number. So now here we're going to do the same thing. The x plus b over 2 squared stays multiplied by the a. But now we're going to have negative b squared over 4a squared times a. So we're going to just put the a in the numerator. So this will be minus ab squared over 4a squared. Back to this problem. The plus 1, we're going to want to make that have the same denominator as this fraction, so it'll be easy to add. So we'll make that 2 over 2. So now in this one, we have to make c have the denominator of 4a squared. Sounds really wacky, but it's actually easy. We just take c, which is in the numerator, and we multiply the numerator by 4a squared, and we multiply the denominator by 4a squared. So it's just 4a squared c over 4a squared. We just stuck a 4a squared in both the numerator and the denominator. Now, we isolate the negative 2 times x plus 9 over 2 squared. And bring all this to the other side, we'll get negative 83 over 2. Same thing over here. Bring all this stuff to the other side. So everything is going to be over 4a squared. On this side of the equation, 4a squared c is positive. On the other side, however, it's going to be negative 4a squared c. And then negative ab squared on this side will become positive ab squared on that side. Okay, now we divide both sides by negative 2 in this one. Dividing by a number is the same as multiplying the denominator of that number, so we'll be left with 83 over 4. In this one, we're going to divide both sides by a. So what we can do to divide by a is just divide the numerator by a, and that will divide the whole fraction by a. So that means negative 4a squared c. The a squared will change to just an a since we divided by an a. So it'll be negative 4ac. And ab squared, we divided by a, so that a is gone, and it's just b squared that's left. We do not divide by a in the denominator, because if we did that, then we would have taken out an a from both, and the fraction would be the same. We divide out of the numerator so that the whole fraction is divided by a. Okay, now we do the square root of both sides. Square root of both sides over here. The square root of, I think it'll be easy if we put the positive term first. The square root of b squared minus 4ac. Nothing to simplify there. Square root of b squared minus 4ac. Square root of 4a squared. Square root of 4 is 2. Square root of a squared is a. And now we see that since they have the same denominator, we can write it as a combined fraction. Bring over the 9, it becomes negative. This one is plus or minus square root of 83 minus 9 over 2. This one is plus or minus the square root of b squared minus 4ac minus b. We brought the b over. The whole thing over 2a. And there we go. That is the quadratic formula. By completing the square for the standard form, in other words, where you can substitute any numbers in for a, b, and c, we have derived a formula that will allow us to complete the square and solve for x in any quadratic formula in one step. All we have to do is all this stuff in here. So This is a very important formula to commit to memory if you haven't done so already. Let me blow it up a bit so you can see it more clearly. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, a, b, and c are just the coefficients in front of x squared, x and c.